let's start this recording. I would like to finally debug my fully qualified name here. So you can see I get b of x of 29, but I would like to get the template argument here as well. So the first question we should answer to have an idea of what's going on is, first off, we need to see what's in that node. Maybe the information is missing. N equals that, and that will give us that node. To introspect it, now we can print what's in that node. That would probably be a lot. But let's see. So we have to create a map for to do with the recursive nature, and then we say from node to string and comma CMap, address of CMap. And now if we run this, we get the tree out. We see that we do get a template instance B, and the question is, does this parent of that template instance does this thing have an argument in it? Yes, here we see it. This is the integer expression with the value 92, and if we look at the line and the column in t.d, we see this is this. So the information to print that is there. Let me quickly show you what it prints. And .fqn. So you so I can see that, and we have to disable the long print out of the tree. It says bx without the information about the 92 in this template argument, and that's not what we want, and we have to find out why that is the case. And we have seen that the information is there. So what we're going to do now is we're going to step through this at runtime. So we do void main this. We assign our node to a variable, and the reason we do that is otherwise the debugger can't see this static immutable. So we call this nd. We assign to n. Now it's in the stack frame rather than in some static segment where the debugger can't see it. And then all we do is we force the break as an end. This forces a break to happen, and then we say auto s equals nd.fqn, and then we should be able to see how this string is being built up. We compile it with debug info, that was quick. Then we say debug, there we go, and we give it t, and that's that, and we run it. And we are breaking here because of this break instruction, and we see the node, the ND node that we have, and we want to step into the FQN function. This is the FQN function that builds a fully qualified name, and now we can basically watch the function build up the string. If we just step over these things, here is the result. That's the string, right? And we can just step over this. Now it starts with the X that comes from our node that is location parent, where the parent is a template instance. Now we will go into the parent. Like if we go there, we will then see that TI down here should be getting set. So we step over it. TI is not set. Why not? Okay. Oh, this is just for when that happens in declaration. Alright, that's still alright. We see that we have a last parent node, and that last parent node is our struct declaration. X. We step over that. We get the parent of that, and if that is a template instance, that will set TI to non-zero, and it is. It is a template instance. It's an eponymous template instance, and it is called X. So now TI is set, which means we step into the code that creates the literal from the argument and makes a string out of that, which is now here. Now we have X of 29. We step over that. We check if we have a last parent node. We do have a last parent node, which is the template instance we just stepped into. And that means we concatenate the name of the declaration we're on onto our name. So we can just step over that. Now we see if that parent is a declaration. We do see that it is, and we also see that the parent of that is a template instance, and the last parent node should now be the same as D, and it is. You can see it. It's just it's pointing to the same node. 536 is what it ends with, and this is also the pointer here. So, and that yeah, is what it is. we step over that, and we should go into here, since we have a template instance as a parent, right? We have this. We have this parent and this template instance, and yeah, we step over that. Parent should be null since it's not a declaration. Right? Yeah, parent is null since it's not a declaration. We set the last parent node to parent. That's fine, because if parent is not able to do anything here, we will set the last parent node to the last template instance we have encountered, and that is X, and then we get the parent from there, which unfortunately is also null. Our issue is that, oh no, it's not. The core reflect. So this is the parent of the template instance. The parent of the template instance is this thing here, and when we do the last parent node get parent, we should get the parent of the template instance. So after this, the value of ti, which right now points to x, should change to point to b. However, that's not the case, because our last parent node is the template instance. We can try casting last parent node to template instance, but I don't think that works. Yeah, it says no simple template instance in the current context, which is a bit bad. What this means is that the last parent node, while it is a template instance, if you call get parent on it, it doesn't seem to work properly. What we can do is set a breakpoint here and rerun this, and then we say step over, and we would get to this breakpoint. So when we hit this here, where we have ti, we can see that ti is x. It is not b. And furthermore, if we were to get the parent of that, we would get the class declaration. that is B. The current declaration we're on, which is B, right, has the same internal pointer, right? The internal pointer of the parent here of our template instance X is the same as B. And we obviously already are in that. So rather what we have to do here is we do not do this, because this doesn't mean that last parent node wasn't proper, right? Right, this means if not parent and last parent node, this means that the last parent node's parent is not a declaration, which may be true, but we do not need to set the last parent node to TI at all, so this line is wrong. And this is something that I could now see because I was able to step through this code. This is very important that you are able to do that even if you're metaprogramming.